structures and unions, learning objectives. In this chapter, the user would learn the following in detail: structure variables, initialization, structure assignment, nested structure, structures and functions, structures and arrays, arrays of structures, structures containing arrays, unions. Data types. C programming language which has the ability to divide the data into different types. The type of a variable determines the kind of value it may take on. The various data types are simple data type, integer, real, void, char. Structured data type, array, strings. User-defined data type, enum, structures, unions. Structure data type. A structure is a user-defined data type that groups logically related data items of different data type into a single unit. All the elements of a structure are stored at contiguous memory locations. A variable of structure type can store multiple data items of different data types under the one name. As the data of employee in company, that is, name, employee ID, salary, address, phone number is stored in structure data type employee detail. Defining structure. A structure has to be defined before it can be used. The syntax of defining a structure is struct. Example of structure. The structure of employee is declared as struct employee. Memory space allocation. Application of structure. Structure is used in database management to maintain data about books in library, items in store, employees in an organization, financial accounting transaction in company. Structure variables. A structure is a collection of one or more variables grouped under a single name for easy manipulation. The variables in a structure, unlike those in an array, can be of different variable types. A structure can contain any of C's data types, including arrays and other structures. Each variable within a structure is called a member of the structure. Declaring a structure variable. A structure has to be declared after the body of structure has defined. The syntax of declaring a structure is: the example to declare the variable for defined structure, employee. Here, E1 variable contains 6 members that are defined in structure. Structure variables program. Output. Initializing structure members. The members of individual structure variable are initializing one by one or in a single statement. The example to initialize a structure variable is accessing structure members. The structure members cannot be directly accessed in the expression. They are accessed by using the name of structure variable followed by a dot and then the name of member variable. The method used to access the structure variables are: the data within the structure is stored and printed by this method using scanf and printf statement in C program. A structure named COORD that contains both the X and Y values of a screen location is as follows. Output. The struct keyword, which identifies the beginning of a structure definition, must be followed immediately by the structure name or tag, which follows the same rules as other C variable names. Within the braces following the structure name is a list of the structure's member variables. The variable type and name must be provided for each member. The above statements define a structure type named COORD that contains two integer variables x and y. They do not, however, actually create any instances of the structure COORD. In other words, they don't declare set-aside storage for any structures. Output. The following program shows the structure for recording students. Output. There are two ways to declare structures. One is to follow the structure definition with a list of one or more variable names. These statements define the structure type COORD and declare two structures, first and second, of type COORD. First and second are each instances of type COORD. First contains two integer members named x and y, and so does second. This method of declaring structures combines the declaration with the definition. The second method is to declare structure variables at a different location in the source code from the definition. The statements also declare two instances of type COORD. Structure assignment. The value of one structure variable is assigned to another variable of same type using assignment statement. If the E1 and E2 are structure variables of type employee, then the statement E1 is equal to E2 assign value of structure variable E2 to E1. The value of each member of E2 is assigned to corresponding members of E1. Program to implement the structure. Output. Individual structure members can be used like other variables of the same type. Structure members are accessed using the structure member operator, open bracket, dot, close bracket, also called the dot operator, between the structure name and the member name. Thus, to have the structure named first, refer to a screen location that has coordinates x is equal to 50, y is equal to 100. The code is as follows. To display the screen locations stored in the structure, second, the code is as follows. What is the advantage of using structures rather than individual variables? One major advantage is that a programmer can copy information between structures of the same type with a simple equation statement. Continuing with the preceding example, the statement first is equal to second, semicolon, is equivalent to this statement as follows. Structures within structures. C language allows a variable of structure type to be a member of some other structure type. The syntax to define the structure within structure is example of structure within structure. Output. Accessing structures within structures. The data member of structure within structure is accessed by using two period dot symbols. The syntax to access the structure within structure is, for example, nested structures. In the example, a defined structure has been dealt with that can hold the two coordinates required for a single point. One needs two such structures to define a rectangle. One can define a structure as follows, assuming, of course, that one has already defined the type coord structure. This statement defines a structure of type rectangle that contains two structures of type coord. These two type coord structures are named top left and bottom right. The preceding statement defines only the type rectangle structure. To declare a structure, one must include a statement such as struct rectangle mybox semicolon. One could have combined the definition and declaration as he did before the type coord. To access the actual data location, that is the type int members, one must apply the member operator dot twice. Thus the expression mybox.topleft.x refers to the x member of the top left number of the type rectangle structure named mybox. To define a rectangle with coordinates 0, 10, 120, one can write structures and functions. In C, structure can be passed to functions by two methods. Passing by value, that is passing actual value as argument. Passing by reference, which is passing address of an argument. Output. Passing structure by value. A structure variable can be passed to the function as an argument as normal variable. If structure is passed by value, change made in structure variable in function definition does not reflect in original structure variable in calling function. Write a C program to create a structure student containing name and role. Ask user the name and role of a student in main function. Pass this structure to a function and display the information in that function. Output. Passing structure by reference. The address location of structure variable is passed to function while passing it by reference. If structure is passed by reference, change made in structure variable in function definition reflects in original structure variable in the calling function. Write a C program to add two distances, feet-inch system, entered by user. To solve this program, make a structure. Pass two structure variable containing distance in feet and inch to add function by reference and display the result in main function without returning it. Output. Passing structure to function. The structure variable can be passed to a function as a parameter. The program to pass a structure variable to a function. Function returning structure. The function can return from a variable of structure type like an integer and a float variable. The program to return a structure from function. Output. Array of structure. C language allows creating an array of variable of structures. The array of structures is used to store the large number of similar records. For example, to store the record of 100 employees, then array of structures is used. The method to define and access the array element of array of structure is similar to other array. The syntax to define the array of structure is structures containing arrays. One can define a structure that contains one or more arrays as members. The array can be of any C data type, int, char, and so on. For example, consider the declaration below. The above statements define a structure of type data that contains a 4-element integer array, member named X, and a 10-element character array member named Y. Program to implement the array of structure. Output. Structures and arrays. One can then declare a structure named record of type data as follows. One can access individual elements of arrays that are structure members using a combination of the member operator and array subscripts. The character arrays are most frequently used to store strings. The name of an array without brackets is a pointer to the array. Because this holds true for arrays that are structure members, the expression is a pointer to the first element of array Y open close bracket in the structure record. Therefore, one could print the contents of Y on screen using the statement arrays of structure program Output. What one needs is an array structures of type entry. After the structure has been defined, one can declare an array as follows. This statement declares an array named list that contains 1000 elements. Each element is a structure of type entry and is identified by subscript like other array element types. Each of these structures has 3 elements, each of which is an array of type char. Unions. Unions are similar to structures. A union is declared and used in the same way as that of a structure. The reason for this is simple. All the members of a union occupy the same area of memory. Unions are defined and declared in the same fashion as structures. In unions, all the members share the space, which is according to the space requirement of the largest member. A union can be initialized on its declaration. Because only one member can be used at a time, only one can be initialized. To avoid confusion, only the first member of the union can be initialized. The following code shows an instance of the shared union being declared and initialized. The generic variable union was initialized just as the first member of a structure would be initialized. Note, the union can hold only one value at a time. Defining of union. A union has to be defined before it can be used. The syntax of defining a union is: to define a simple union of a char variable and an integer variable, one would write the following. This union, shared, can be used to create instances of a union that can hold either a character value, C, or an integer value, I. This is an OR condition. Unlike a structure that would hold both values, the union can hold only one value at a time. Structure and unions union. Example. Output. Union data type. A union is a user-defined data type like structures. The union groups logically related variables into a single unit. The union data type allocates the space equal to space needed to hold the largest data member of union. The union allows different types of variable to share same space in memory. There is no other difference between structure and union than internal difference. The method to declare, use, and access the union is same as structure. Memory space allocation. Accessing union members. Individual union members can be used in the same way that structure members can be used by using the member operator, open bracket, dot, close bracket. However, there is an important difference in accessing union members. Only one union member should be accessed at a time. Because a union stores its members on top of each other, it's important to access only one member at a time. The following is an example for this. Output. Union example. Accessing union members. Output. Difference between structures and union. The memory occupied by structure variable is the sum of sizes of all the members, but memory occupied by union variable is equal to space held by the largest data members of a union. In the structure, all the members can be accessed at any point of time, but in union, only one of union member can be accessed at any given time. Conclusion. In this chapter, we have covered the following aspects of structures and unions: structure variables, initialization, structure assignment, nested structure, structures and functions, structures and arrays, arrays of structures, structures containing arrays, unions.